is intersection of two linked lists. Given the heads of two single linked lists, head A and head B, return the node at which the two lists intersects. Okay, so we can solve this problem basically two ways. One way will be using a hash set, and the second way will be using a two-pointer solution. So let's see the first approach using a hash set. So we have our two linked lists here. So the first is linked list A, suppose, and second one is linked list B. What we can do, we can create one set and we'll navigate our linked list 1 node by node and we'll store all the elements. So this will navigate from A1 to C3. So while navigating, it will first store A1, then it will now move over to A2, it will store A2, then C1, then C2 and C3. So by the end, all our nodes will be stored in the set. Now the next step, what we can do is we can navigate over the second linked list B, and while navigating, we can compare each node if it is present in the set. If it is present, then that will be our intersection point, and you can simply return. And if it is reaching till end and we didn't found our intersection point, we can return null. So there is no intersection point. So we'll start with B1. We'll check. Okay, B1 is present. B1 is present in set. No. Then move over. B2. B2 is present in set. No. Then B3. B3 is present in set. No. Then we'll go to C1. Okay, C1 is present in set. Yes. Then C1 will be our intersection point. Let's code. So as I said, we can create a set first. Okay, set of our, it will be of list node type. Set of list node set equals to new HashSet. Okay, now what we can do, we can iterate over the first linked list. So while our root node is head A, while head A not equals to null, so we have to add each node to the set. So set dot add head A. So then move over to the next node. Head A equals to head A dot next. Now by this end of this while loop, all the nodes of the first list node will be added to the set. So in the next step, what we can do, we can iterate over the second list node, that is head B, and we'll check if each node is present in the set. So what we can do, we can iterate while head B not equals to null. Okay, and check if set dot contains head B. If it found, then that will be our intersection point. I can simply return head B. Now if it doesn't found that node, we can navigate to the next node. So head B equals to head B dot next. Now after completing this while loop, if still we didn't found our intersection node and we reach the end, so there is no intersection point, and we can simply return null. Let's run the code. Okay, this is working fine. With this approach, the time complexity will be order of n and the space complexity will be order of n. Why? Because here we are navigating the first linked list, that will be order of n time. Here we are navigating the second linked list, that will be order of n time. So order of 2n time, that will be time complexity is order of n. And since we are storing each the first linked list, each node in the set, so the space complexity will be order of n time. Now in the next approach, let's see the second way of finding the intersection. That will be using a two pointer solution. So why will that be better? Because here we have time complexity as order of n and space complexity is order of n. Time complexity we can't reduce from order of n. So space complexity we can improve if we are going through two pointer solution. We no need to store in a set, so we'll save the space complexity as order of 1. So let's see that. Okay, let's see the second approach using a two pointer solution. If both the list nodes have same number of nodes, it will be a straightforward solution. So what I meant is, if we have a node here, so now I can put a pointer here P1 and I can put a pointer here P2. Every time I can move P1 to the next node, to A1, then to the next node, then to the next node, and P2 I can move B2, B3 and C1. Now I can compare, okay, P1 and P2 both are at the same place, so I can return, okay, C1 is my intersection. But since we don't have the same length of the list nodes, what we can do here is, okay, let me test this. What we can do is, I'll put my pointer here P1, I'll put my pointer here P2, I'll navigate till the end of the first list node. Once P1 reaches here, I can put P1 back. I can put P1 back to the start of list node 2. So what we can do, once P1 reaches here, I can put P1 here. Now similarly, P2 I can navigate till the end of the second list node. Once P2 reaches here, I can take P2 back to starting up P1 and then continue the navigation. So I can continue the navigation, and here also I can continue and I can compare. So with this approach, what will happen? Okay, here I have my P1, here P2. Okay, now let's navigate. P1 will be here, P2 will be here. I can compare, okay, both are not equal. Then P1 will be here, P2 will be here. I can compare, okay, both are not here, both are not equal. Then P1 I can move here, P2 I can move, both are not equal. Then P1 at C3, P2 at C2, both are not equal. So then, as I said, once P1 reaches at the end of that that list node, move P1 to starting of the second list node, and P2 I can move to C3. Now again P1 will be on the next node and P2 will be beginning of the list node A, linked list A. And again P1 I can move here and P2 I can move here, and then P1 I can move here and P2 I can move here. So both the list nodes now, P1 and P2 are at the intersection. The node is C1. I can return C1. Code for the second approach using a two pointer solution. Let me clear this thing out. So what I can do is, I can take a pointer. My pointer will be, first pointer will be list node P1 equal to head A. Okay, second pointer will be list, sorry, my bad, list node P2 equals to head P. Okay, then what I can do, I can put it in a while loop. While P1 not equals to P2, then I can move forward. So if, as I said, if P till the point P1 reaches the end, it will be null. So if it is reaching at the end, just move the pointer to the second linked node, the beginning of the second list node. So what I can do is, I can directly write like this: P1 equal to, now P1, if P1 equals to null, then assign the value of beginning of the second list node, that will be head P, else move forward P1 dot next. So similarly P2 I can assign, okay, if P2 equals to null, that means it reaches the end of the second list node. I can assign to beginning of the first list node, head A, else P2 dot next. It's a very simple solution. Only tricky part is we have to know by the time it is reaching the end, if it is still not, the intersection is still not there, just assign the second point, the pointer to the beginning of the other linked list, so that the whole length will be equal. So you can see return PA, return P1. If I'll run my code now, okay, good, it is working fine. So what will be the time complexity? The time complexity, since we are just iterating only one while loop, the time complexity will be order of n, and the space complexity will be order of 1, because we are not storing any data, we are simply iterating through the two list nodes. So our space complexity will be order of 1.